Welcome back to Think Thrice Problem Solving. Let's take a look at the problem we're going to solve today. So looking at this one, we have a battle of two expressions. So the expression on the left is the sine of the cosine of theta, and the expression on the right is the cosine of the sine of theta. So our goal is to say which one of these guys is bigger and over what intervals of theta. So if you'd like to try this out on your own, go ahead and pause the video. Otherwise, we're going to jump straight into our solution. So what I'd like you to do first is I'd like you to think of just this portion of the unit circle from 0 up to pi over 2. So this is pi over 2, this is 0, so 0 to 90 degrees. And this is a unit circle, so we're going to think of the length here as the length 1. And I'm going to draw in my little triangle. So since this is a unit circle, our sides are going to be cosine theta because it's x over r, and r is 1. And this guy is going to be sine of theta. So if we're dealing with values over the interval from 0 up to pi over 2, so for these angles, we're always going to have I'm missing one little short portion. So we're going to keep moving. So let's look at this arc length. So the arc length, so we can see that the arc length of a circle is 2 pi r. So for my unit circle, the radius is 1, so it's just going to be 2 pi. So whatever my angle is, so we can imagine that my length of some arc, so if I label this my arc, so the length of that arc is going to be theta divided by 2 pi, multiplied by my overall length, 2 pi, which is just going to end up giving me an arc length, which is my angle. So the length of this is my angle theta. So take a minute, try to work through that if that's confusing, but the arc length there will be theta. So what I want you to note is that for the angles from 0 to pi over 2, if I have sine of theta, which is perpendicular to the horizontal axis, and I have theta, which is the length of that arc, I'm always going to have that sine of theta is less than theta, as long as I'm between 0 and pi over 2. And we can clearly see that because the shortest distance between my point on the unit circle to the horizontal axis is always going to be sine of theta, because it's perpendicular. Okay, so if I have sine of theta less than theta, so first off, we're dealing with for 0 is less than or equal to theta is less than or equal to pi over 2. We're going to have sine of theta, since I'm including 0, it's going to be less than or equal to theta. Okay, so we're given that. So the next thing I want you to note is that if I look at this horizontal portion, so if I'm looking at the cosine of theta, for this interval, cosine of a smaller angle is always going to be bigger than cosine of a larger angle. So if I take cosine of, let me draw that out, so let's say I'm looking at this circle. If I take cosine of this angle, I'm going to have this guy. If I choose any angle that's bigger, I'm going to have this much smaller portion. Okay, so for this interval, for any value of theta, the bigger the angle of theta, the smaller the value of cosine. So, since we know that sine of theta is less than theta, that means that cosine of the larger angle, which is theta, is going to be less than or equal to cosine of the smaller angle, which would be sine of theta. Okay, since sine of theta is less than theta, cosine of theta will have to be less than cosine of sine of theta for this interval. I want to keep reiterating this is for this particular interval. Okay. The next thing I want you to look at is, let's imagine that I have the angle cosine of theta. So cosine of theta is greater than or equal to 0, and it's less than or equal to pi over 2 for this interval. So if I'm taking this value, I'm always going to have cosine theta between 0 and pi over 2. It's actually going to be between 0 and positive 1. But what that means is that using the identity above, the sine of cosine of theta is going to be less than the cosine of theta. So I'm just doing a quick substitution, and I'm saying since cosine of theta falls within those values, that expression will still be true. So what we've just shown is that sine of theta, and I'll kind of rewrite this a little bit. So this is less than or equal to 1, which is exclusively less than pi over 2. So what we've just shown is that sine of cosine of theta is less than cosine of theta, which is less than or equal to cosine of sine of theta. So what does that tell us? Take out the middleman, and we've just shown that for 0 is less than or equal to theta is less than or equal to pi over 2, sine of cosine of theta is less than cosine of sine of theta. Great. So that's the start of our little adventure here. So now, what I'd like you to do is let's consider negative pi over 2 is less than or equal to theta is less than or equal to 0. Okay? So in this case, I want you to note that let's first look at sine of cosine of theta. So since cosine of negative theta is equal to cosine of theta, I now have that sine of cosine of negative theta is equal to sine of cosine of theta. Additionally, if I look at this guy over here, cosine of sine of theta, so sine of negative theta is negative sine of theta. And then cosine of negative sine of theta is equal to cosine of sine of theta, which, if we look at it, now I've just shown that sine of cosine of negative theta is going to be equal to sine of cosine of theta, and cosine of negative sine of theta is equal to cosine of sine of theta. So once again, we've already shown that they fall into that equality. So for negative pi over 2 is less than or equal to theta is less than or equal to 0, it must be true that sine of cosine of theta is less than cosine of sine of theta. Okay? So then the last set of points that we need to look at. So let's look at the angles where pi over 2 is less than or equal to theta, which is less than or equal to 3 pi over 2. So when we're looking at these angles, what I want you to note is that for all of these angles, I'm going to draw the unit circle here again. So we're looking exclusively in this region of our circle. So for all of these angles, and let's make these not inclusive, because we've already had the inclusive, we're going to have cosine of theta is less than 1. So is less than I'm sorry, I'm kind of being a mess here. So negative 1 is less than or equal to cosine of theta, which is less than 0. Okay? What that means is that sine of cosine of theta is going to be sine of a negative and it's a negative value between 0 and negative 1. So for all of those values, I'm going to have a negative number. So this is going to be less than or equal to 0. Or sorry, since it's not 0, it's going to be exclusively less than 0. So sine of cosine of theta is going to be less than 0. Now continuing, I know that for this entire interval, negative 1 is going to be less than or equal to sine of theta, which is going to be less than or equal to 1. But we've already shown for all of those values, so from negative 1 to 1, my cosine is always going to be positive. So for those values, cosine of sine of theta is going to be greater than 0. And since cosine of sine of theta is greater than 0 and sine of cosine theta is less than 0, we can see that cosine of sine of theta is greater than sine of cosine of theta. So we've just shown that for any values from negative pi over 2 to 0 and any values from 0 to 3 pi over 2, cosine of sine of theta is always greater than sine of cosine theta. And then since sine of theta is equal to sine of theta plus 2 pi times any integer, and cosine of theta is equal to cosine of theta plus 2 pi n, we can therefore say conclusively that cosine of sine of theta is greater than sine of cosine of theta for all thetas in the real numbers. All right, and then just to close out here, I'm going to kind of show you what this will look like. So if we were to go ahead and plot this, so if you were to plug this into Desmos, for example, we would end up having our two functions. So if I go out to pi on the right and I go out to negative pi, then I'm going to have one function which goes something like this. And this is going to be cosine of sine of theta. So this is my theta axis right here, and this is 1. And then if I was to plot negative, or sine of cosine of theta, I'm going to have a value which is less here. It's going to go down, and it's going to be sinusoidal, looking something like this. And then this will continue. It'll continue every time we add pi. We'll just get the same 2 pi. We'll get to the same graph over and over. All right, so I hope you enjoyed working through this problem with me. There are a number of ways to solve this. I thought this would be the simplest way so that most people can understand what was going on. If you enjoyed this problem, please like and subscribe. If you have your own problem that you'd like me to work through, please submit it, and you might see it in a future video. And if you are doing problems on your own, think once, think twice, and if you get stuck, think thrice. Thank you.